Hi everyone, my name is Sanjay Kumar. I'm the Vice President of Product Management and Marketing at Arrcus.
Hi folks, my name is Keyur Patel and I'm a founder and CTO here at Arrcus.
Thanks so much, Jim, for having us. I think the overarching question today is how do you deal with the distributed nature of AI? For several reasons, the need for sovereignty, the need for privacy, the need for inferencing applications at the edge, all of this is driving AI workloads to be far more distributed than were originally envisioned. At Arrcus, we have actually, we outlined this vision about a year and a half back, recognizing that AI was not going to be a centralized problem that needed to be solved, but more of a distributed problem that needed connectivity. In order to address that, our architecture essentially focuses on providing a network fabric that's going to help stitch all of these different workloads together in a seamless fashion and a secure fashion, and at the same time helping operators deliver the AI applications where they're needed with the kind of latency that's required. If you double click on this, essentially what that means is within a data center, however big or small that might be, you're going to need GPUs that are you need GPUs to be connected to each other, and that's what we refer to as scale-up networking. You need multiple GPU racks for scale to be connected with each other, and that's what is referred to as scale-out networking. And then what you also need is a stable, secure, and scalable connection between data centers, and that's what's referred to now as scale-across networking. We've been referring to that as data center interconnect, and that's one of the key sort of value proposition that we provide customers is the ability to be able to connect all of these workloads and access them in a seamless distributed, with a seamless distributed networking fabric. Okay?
Very cool. As Sanjay said, and he explained it beautifully, what each points in the AI networks are. And for each and every point, you have different requirements from a fabric standpoint. What we have managed to do, as Sanjay was saying, we saw this very early on, and we have managed to come up with a fabric that is scalable, that is highly secured, that is fully programmatic, and can be orchestrated on demand, whether you are looking at scale up, scale out, or scale across, connecting different data centers. Yeah.
Thanks, Keyur. And I think what you'll find today is you've got multiple stakeholders in this entire AI network, so to speak. You've got customer segments like telcos, you have co-location providers, you have the hyperscalers, you have enterprises, you have neoclouds, all of which are going to need to access multiple networks and multiple resources, and the ability to pull all of this together is going to be a fairly complex problem. And at Arrcus, we're really excited to be able to address this. Now, apart from having this unified network fabric, one of the things that we do differently from anybody else is our ability to abstract our operating system from the underlying hardware. So we can run on any kind of hardware platform purpose-built for a particular application or a particular use case, and that could be based on merchant silicon, whether it's based on Broadcom silicon, or for that matter, it could be based on NVIDIA silicon, it could be compute resources in the form of x86 or ARM cores, and by doing so, we provide customers with a very wide range of choices that allow them to be able to innovate at AI scale, at the pace of AI, really, and have that flexibility, and at the same time be able to deploy that wherever it's necessary. So that flexibility, I think, comes to bear and is even more important than it ever has been before, since AI is moving so quickly and the requirements are evolving so rapidly. Okay.
Totally. we've seen a number of things. Ethernet is starting to become a first-class citizen as you start to look at AI networks, whether it's training or inferencing. You're also to that point seeing different and lot more vendors coming up with different hardware solutions, targeting Ethernet as a fabric. And all this means, to what Sanjay just said, is that the network is going to grow and it's going to support a lot more different kinds of hardware. And what would be cool for any network operator is to have that single unified fabric, particularly when they're managing AI networks at scale. And if they can do this in a very efficient manner, that would be tremendous in terms of savings, whether it's CapEx or OpEx, moving forward for the AI networks, yeah?
Yeah, and speaking of unified, I think another key element that has to be considered is you have the back-end network for GPU connectivity. At the same time, you also have the front-end network that exists for IT purposes, for high-performance compute connectivity, storage connectivity. And again, rather than having silos, you want to be able to unify all of these different elements. And that's what we provide at Arrcus, is a unified network fabric that will help connect all of these different elements, making the operator's life much simpler as they look to roll all of this out.
Yeah, and these different points in the network has different characteristics, right? So if we look at visibility, for example, visibility in scale up means something, and it means totally something else as you start to look at scale out. And scale across, it means completely different in sense that how do you make sure that the links sort of stay up all the time, or if they're going down, how do you avoid that end-to-end traffic re-announcements or reconverging? How do you do fast reconvergence and stuff like that once you have a visibility in place? So not just visibility, but solutions vary depending on what point in the network you're talking about. And then again, bringing this all back into a unified networking fabric is quite interesting, particularly when you start to look at different silicons being deployed at this different points of the network. Yeah.
Right. And speaking of different requirements, one of the key requirements is, at the end of the day, what you're trying to do is maximize your GPU utilization, or the utilization of your GPU resources, and need to make sure that the network supports that. And in order to do that, what you need is a lossless fabric. You need congestion management, and you need to make sure that you're taking care of, entropy. You're taking care of elephant flows as well, and all of these requirements, as you said, will be different for a training workload versus an inferencing workload, which probably requires an inferencing workload. Probably requires lower latency, probably less bandwidth. And recognizing all of these different requirements is essentially what we've been doing at Arrcus in order to be able to come up with this comprehensive network fabric that can extend across locations, extend across geographies, and at the same time be able to address the specific requirements of those different workloads. And one other thing that we've been doing at Arrcus in terms of helping connect these distributed resources in a way that nobody else can do is helping tie together private infrastructure with the hyperscaler infrastructure. So sort of multi-cloud networking or hybrid cloud networking. And that adds another layer of flexibility for from a deployment perspective that we do quite uniquely compared to anybody else.
Yeah, and Sanjay, we have seen a transition from 100 to 400 gigs and now 800 gigs.
Yeah.
1.6 tera is around the corner. And so the other thing is, how do you sort of manage the hardware transitions in Ethernet? And most of the times we have seen that the fabrics remain stable once you have scalable fabric in place. But if you can manage to swap the hardware out underneath it and allow the networks to scale alongside with the next generation GPUs, that would be phenomenal, yeah?
Yeah, absolutely. So I think that is one of the what makes this particular transition so different from everything else that's happened in the past is the rapid change of requirements. That requirement for being able to deliver innovation at the pace of AI is extremely important for operators. And the way that we do it at Arrcus, which is to abstract the hardware and let our operating system run on any kind of hardware, essentially gives the operators a great deal of flexibility and the ability to upgrade at their own pace without worrying about the network operating system itself. And compared to what has been that has been sort of useful in the past, which is having a hardware-centric view of the network, is no longer enough, or doesn't cut it any longer in the world of AI, simply because the requirements are changing so rapidly, so recognizing that you're going to need different form factors, you're going to need converged form factors. In some cases, you need to pay very close attention to how much power is being consumed, and therefore power efficiency becomes really important. And that's the kind of work that we're doing at Arrcus to help operators be able to deploy this at scale and in a much more efficient and cost-effective manner.
And another point that I'd like to bring out while we talk about different kinds of hardware, the same applies to the software. Mm-hmm. One big benefit of having a seamless fabric is that there are no point solutions in network. Mm-hmm. And for the fact that you have a common software or a seamless fabric, one big benefit to that is tremendous amount of savings when it comes to managing the network, right, in terms of capex and opex. And this becomes even more important when you are targeting a network like AI, where latency matters, jitter matters, end-to-end delay matters. You want scale, and therefore having something that is manageable, fully automated, it would be a big benefit as well. Yeah.
Yeah, and one other thing, Keyur, if you might want to address which is switching versus routing. How does it manifest itself in this particular use case, and what are your thoughts around that?
Yeah, I think when you look into a data center, we've always focused on switching. We've always focused on how do you build that fabric simple enough but fast, and it gets to support multi-tenancy at scale, data separation, whatnot that you look into the data centers. And when you start to go scale beyond data centers, whether it's DCI or whether it's a network that stitches the data centers together across multiple networks, routing becomes a first-class citizen. At that point, a lot of things matter because you wanna be able to react to link failures, node failures if there are any, and how do you sort of work around to that? And therefore, that fabric has to be super intelligent to do not just switching and routing, but automation, like we talked about, to be able to reconverge, to be able to support traffic engineering at scale, and do support visibility. And visibility matters, as we talked about, at different points in the network. So what kind of visibility do you support between inter-data center also becomes very important.
Looking forward, to what's next. It is definitely exciting times. Standards are evolving. We're firmly on the camp of Ethernet, because we believe that this is the most scalable, mature, and cost-effective technology that there is.
And history has shown us.
And history has shown us that the Ethernet tends to deliver where no one else can. So with that, we see that the ecosystem is coming together to define standards, whether it's UEC, which we are a part of and we continue to contribute to. You've got UE transport at this point of time. And now to address scale-up networking, we're quite excited to see how the ecosystem is coming together to define standards for scale-up Ethernet, SUE transport. Now there's eSUN as well that was recently announced. So we're very excited to be able to contribute and leverage all of those standards to be able to deliver these capabilities to the customer. But again, what we bring to the table and that makes us different is our ability to do switching and routing in a far more scalable and performant fashion, the ability to have low convergence times, for example, the ability to give that internet scale is going to be extremely important, and at the same time being able to do that across a wide variety of hardware platforms, delivering that choice to the customer, the flexibility as well as the pace of innovation, that sort of sets us apart from the other vendors in the marketplace in being able to deliver this unified network fabric for AI to customers.